So number 18, let's graph and state the domain and range of each graph. So the best way to do this would be to identify h and k and then ignore h and k. So what's your h value? Positive 3. Your k value? 0. So positive 3 means you're going to move your coordinates 3 units to the right. 0 means you're not moving up, you're not moving down. Okay? In case you forgot, here's your form. Y equals A. The letter in the front tells you if it's opening up or down. The h and k value, h is always inside with x, and you have to think opposite of whatever you see. That's why there's a minus sign in front of it. The k is a plus k, which means that whatever number is added or subtracted out here at the end, that's what you're moving up or down. You take it for what it is. So you think opposite on h, you take k for what it is. So once you've identified h and k, it's always a great idea to go back to your original, and I like to box this in, ignoring h and k. So now I could pretend that that's the equation y equals negative square root of x, and that's it. Y equals negative square root of x. And then I go for an xy table with that simple radical function. And then I plug in some nice perfect square numbers. Like 0 always works. The square root of 0 is 0, and with the negative in front, it's still 0. The square root of 1 is 1, but with the negative in front will be a negative 1. The square root of 4 is 2, but with the negative in front, it'll be negative 2. The square root of 9 is 3, but you end up with negative 3. Everybody with me? Cool. Bless you. So we have those coordinates. Let's graph those coordinates. We have 0, 0. Whoops. 0, 0 right there at the origin. We have 1, negative 1 right there. We have 4, negative 2. 1, 2, 3, 4, negative 2. There it is. We have 9, negative 3. 9, negative 3 right there. Now I'm not going to draw my graph through there because this is not including h and k. So what I need to do is take those red dots and I'm going to change them to blue after moving them according to h and k. And we see that h is 3. So we just need to move each of these dots. So I want to take this one and move it over 3 units right there. Same thing with this guy, 3 units right there. This guy 3 units, 1, 2, 3. And the last one, it's going to actually go off of the graph, but that's okay. You're going to go 1, 2, 3 out there. So graph those dots and you're done. Now, of course, on your test, you're not going to have to actually graph. They're going to give you 4 different graphs. All you got to do is see if it's opening the right way, see if it's shifted the right way. They'll probably put the same graph right here, but shifted 3 this way to see if you know to think opposite on h. Or maybe opening up instead of opening down. So it's already going to be graphed for you, but that's how you do these. Let's try another. What's our h value here? Negative 1. What's our k value? Negative 3. Okay. That means you're going to go 1 to the left and you're going to go 3 down. After you have h and k, ignore h and k. We're going to get the same exact coordinates as we did on this other parent graph y equals negative square root of x. So we could use those coordinates again, 0, 0, 1, negative 1, 4, negative 2, and 9, negative 3. Those are all coordinates. So let's plot them and then we'll shift them. So 0, 0. 1, negative 1, 4, negative 2, 9, negative 3. And let's shift them all 1 to the left and 3 down. So if you take the original one, 1 to the left and 1, 2, 3 down, you end up right here. The other one's 1 unit diagonal from it that way. So this would be your graph right there. Could we move on? Last one. What's our h value? K value? Negative 3. So we're going to be going down 3 units at the end of it all. And let's now ignore our h and k. Right? So this is just the regular y equals square root of x. The easiest type of radical, the parent graph of all radicals. So if you think about it, what's the square root of 0? 0. Square root of 1? 1. Square root of 4? 2. Square root of 9? 3. All right. 0, 0, 1, 1, 1, 2, 3, 4, 2, and 9, 1, 2, 3. All we need to do is take those red dots and move them where? Down 3. Down 3, down 3, down 3. All of them down 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So there's our graph right there. Done. Let's move on. Page. So, number 19. Whew. We have a radical. What can we do with the square roots? What can we do with them? Split them up. That's right. So, this is, I said square root, I'm sorry, a fifth root. We're going to split up that fifth root. So you really have the fifth root of 1024, which I don't even know what that is, to be honest with you right now. And we're going to split the fifth root over here to the x to the 15th. I know that one. That one's pretty easy. That one's going to be x to the third, because we know that it's always power over root when you change a radical to a rational exponent. But anyway, the first part, the fifth root of 1024, we are all able to use calculators. So you could go ahead and use the calculator to find out what the fifth root of 1024 is. So on the calculator, I just got the number 4 and multiplied it by itself with itself 5 times 4 times 4 times 4 times 4 times 4. That is 1024. So my answer is 4 right here. Okay, and if you know how to change a radical to a rational exponent, remember it's the base, and it's always going to be power over root as an exponent. So I'm really going to have an x power over root. That's going to be 15 over 5. And 15 divided by 5 is just 3. So my final answer is 4x to the third power. Ta-da! Let's try this next one, number 20. Again, we're going to split the root. This is a square root. I like those. They're easier. So you have the square root of 25 a to the 7th over the square root splitting it, 81 b to the 8th. Okay, so what we're going to do is tackle each one of these like if there were their own problem. So let's ignore the denominator. Let's just focus in on the top. If I had this problem, the square root of 25a to the 7th, I would split the root. I'd have the square root of 25. I'd have the square root of a to the 7th. And the square root of 25 is 5. Now, the square root of a to the 7th, I want to change that to a rational exponent. Or I could rewrite the a to the 7th as a squared times a squared times a squared times a to the 1, right? But I would rather get used to changing it to a rational exponent. That'll be a to the 7 halves, 7 over 2. 7 over 2. Now 7 divided by 2 is really a mixed number, a to the power of 3 and 1/2, correct? And a to the power of 3 1/2, you could split that a and make it a to the third times a to the half. But of course, a to the half is really the square root of a. Okay? So what do we have on the top? We have 5, we have a to the third, and we also have the square root of a left over. So up on top, we have 5, no, I'm sorry, no square root. We have 5 a to the third square root of a. That's the first part of our answer up on top. Now let's write the denominator. We're going to treat the bottom exactly the same, which is a lot easier, because when you split the root on the bottom, you're going to have the square root of 81, which is 9, and you're going to have the square root of b to the 8th. Now if you change that to a rational exponent, it's always power over root. So it's the power of 8 over the root 2, because it's a square root, and 8 divided by 2 is 4. So you really end up with a b to the 4th on the bottom, and there's your final answer right there. 5a to the third square root of a over 9b to the fourth. Number 21 is pretty easy. Just simplify and then combine the terms that are alike. So as of now, you can't subtract 8 square root of 45, take away 6 square root of 5, because the radicals are different. You can't add this guy with this guy because the radicals are different. So let's simplify anything that we could first. Like the square root of 45, I could rewrite that as 9 times 5, splitting the root. And the square root of 9 is really 3 square root of 5. But then again, don't forget about this 8. That's really an 8 times 3 times the square root of 5. So the first term is really 24 square roots of 5. And then you bring down the second term, minus 6 square root of 5. You could actually do that. 24 take away 6 is 18. We'll do that in a bit. But let's continue working with the square root of 20. The square root of 20, you could rewrite it as 4 times 5. And then split the square root. Of course, bring down the 4. So you're going to have 4 times 2 times the square root of 5, which means that you're going to really have a positive because there's a plus right there, 8. 4 times 2 is 8 square root of 5. So if you look at your 3 terms now you have all the same square root of 5s. So now you could actually go 24, take away 6, plus 8. Because they're all like terms, you could just add and subtract them. So that's really going to be a final answer of 26 square roots of 5. So before we move on, let me go back to this answer on number 20. That's technically not written right. If you take a look at my 3, it looks like it's a third root of a, which is not correct. That's a to the third. So let me rewrite this answer once again right here on the side. The answer number 20 is 5a to the third square root of a over 9b to the fourth. That is my answer. Okay, so that 3 belongs to the a. This is a square root separate. It's not a third root. The numerator, this actually is a pretty easy question. If you look at the denominator, the square root of 81 is 9. The square root of b to the 8th, that's really 4. Because taking the square root of a number is kind of like dividing that exponent by 2. Or taking the square root of b to a certain number is kind of like dividing that exponent by 2. So there's really a 9b to the 4th. That's easy. Up here, another way of doing it, if you didn't want to go the route of mixed numbers and splitting the base, let me do this on the side over here. The square root of 25a to the 7th. Technically, you could rewrite that as a square root of 25, and a to the 7th, you could rewrite it as a to the 6th times a to the 1, right? Yes or no? Okay, so this is just another way of doing it. If you don't want to go the mixed number route and splitting the base, you could rewrite your a to the 7th as a to the 6th times a, and the a to the 6th, the square root of a to the 6th, that's a to the 3rd, and the square root of 25 is 5. No more square roots. The only square root you have is on this one. So some people actually like this method better. I got so used to changing the radical to a rational exponent. I got used to this. Oh, the 7th, the square root of a to the 7th, I could rewrite that as 7 halves. 7 divided by 2 is 3.5. I could split the base, but some people like rewriting a to the 7th as a to the 6th because they know that the square root of a to the 6th is 3. The square root of a just comes down. So anyways, that's the numerator part over the denominator, which will give you that final answer, 5a to the 3rd square root of a over 9b to the 4th. Sorry for jumping back to a previous question. I apologize.